What is single sideband, SSB, on shortwave radio? Have you ever wondered how people communicated across vast distances in the 1950s? One of the key technologies that made this possible was single sideband, or SSB, on shortwave radio. This method of transmitting radio signals was a game changer during that era. It allowed for clearer communication over long distances, which was essential for both amateur radio operators and commercial users. So, what exactly is single sideband? In simple terms, SSB is a technique that uses only one sideband of the radio frequency spectrum to carry audio information. Unlike older methods like amplitude modulation, which used both sidebands, SSB is much more efficient. By using just one sideband, SSB reduces the bandwidth needed for transmission and improves resistance to interference. This means clearer audio and less static, which was a big deal for radio enthusiasts. In the 1950s, many amateur radio operators took to building their own SSB equipment. They often used a method called phasing to create the sideband signals. This technique involved manipulating two signals to cancel out the unwanted sidebands. While it required a fair amount of technical skill, it was a popular project for hobbyists who loved tinkering with technology. The early 1950s saw the introduction of commercial SSB transmitters, marking a significant step in radio technology. However, it wasn't until the 1960s that SSB really took off in popularity among amateur radio operators. They appreciated the improved signal quality and efficiency that SSB offered compared to traditional amplitude modulation. From a nostalgic viewpoint, SSB represents a fascinating period of innovation in communication technology. It highlights the creativity and resourcefulness of amateur radio enthusiasts who were eager to push the limits of what was possible. The development of SSB also mirrors the broader technological advancements of the 1950s, which transformed how people connected with each other across the globe. Practically speaking, SSB provided several advantages over amplitude modulation. It delivered better audio quality, reduced interference, and made more efficient use of the available bandwidth. This efficiency was particularly important for long-distance communication, which was the hallmark of shortwave radio. As we reflected on the rise of single sideband in shortwave radio, it captures the spirit of an era where technology was driven by passion and curiosity. It reminds us of a time when connecting with others around the world was both a challenge and an adventure. The thrill of making those connections was a significant part of the amateur radio experience, and single sideband played a vital role in that journey.